Hello and good day to you. Come, pull up a chair as we venture into exploring the fascinating subject of thoughts are all over the place on the underthinking of O1-like LLMs. This insightful piece of research comes to us from the collaborative efforts of Tencent AI Lab, Soochow University, and Shanghai Jiao Tong University. Today, let's explore the phenomenon known as underthinking in large language models, particularly those similar to OpenAI's O1 model. These advanced models have demonstrated significant abilities in tackling complex reasoning tasks. However, an interesting pattern has emerged. They often switch between different lines of thought without fully exploring promising paths that might lead to correct solutions. This tendency to prematurely abandon a line of reasoning results in inadequate depth of thought, especially noticeable when the models face challenging mathematical problems. The researchers conducted experiments using three demanding test sets: Math 500, GPQA Diamond, and AIME. They evaluated two open-source models akin to O1, specifically QwQ-32B-Preview and DeepSeek-R1-671B. Their observations were quite revealing. As the difficulty of the problems increased, the models generated longer responses and switched thoughts more frequently. However, this frequent switching didn't necessarily lead to correct answers. In fact, it often resulted in incorrect responses due to insufficient exploration of each reasoning path. To systematically analyze this issue, the team introduced a novel metric to quantify underthinking by measuring token efficiency in incorrect answers. Token efficiency refers to the proportion of the model's response that effectively contributes to reaching correct thoughts. They discovered that in incorrect responses, the models consume significantly more tokens, essentially using more words, without effectively progressing toward the solution. For instance, when the models answered incorrectly, they used more tokens per thought compared to when they answered correctly. This indicated that the models were not utilizing their computational resources efficiently, often expending effort on multiple lines of thought without delving deeply into any single one. Addressing this challenge, the researchers proposed a new decoding strategy called the thought switching penalty, or TIP for short. Decoding strategies are methods that guide the model in generating responses during the language generation process. The thought-switching penalty works by discouraging the models from making premature transitions between thoughts. By applying penalties to certain tokens, specific words or phrases that signal a switch in thought, the models are encouraged to thoroughly explore each line of reasoning before considering alternatives. In simpler terms, TIP nudges the models to stick with a promising idea a bit longer, much like we might do when we're trying to solve a tough problem ourselves. The results were noteworthy. Implementing TIP improved the accuracy of the models across all the challenging test sets, without the need for additional model fine-tuning. For example, on the Math 500 test set, accuracy increased by a significant margin. This means that simply adjusting the way the models process information can lead to better performance. It's a practical solution that enhances their problem-solving capabilities, making them more efficient and effective. In conclusion, This research sheds light on the reasoning inefficiencies present in advanced language models and offers a tangible method to mitigate underthinking. By encouraging deeper exploration of reasoning paths, we're a step closer to developing models that mimic human-like deep thinking, especially in complex problem-solving situations. It's an exciting advancement in the field of artificial intelligence, highlighting how subtle changes in approach can lead to significant improvements. Thank you for joining me on this intellectual journey into the intricacies of language models and their thought processes. Until next time, keep questioning, keep exploring, and most importantly, keep thinking deeply.